mainly deals with the data dependency problems. This model have the programs or tasks which are working in a concurrent manner, and the particular program or a particular task can wait for the other task to complete, or it can take the data from the other task. It can wait for up to a given time period, and it can take up the data, and it can deal with the other processes also. So this concurrent model is very good, uh, that is very good given for the data dependency problem. So here you can see that this is the same example as a chocolate vending machine. Here we may model the get user interface and deliver chocolate, read coins, display weight, and display thanks. These are all the processes that we got to deal with the sequential program also. Here you can model that particular chocolate vending machine with the concurrent model also. How we are going to model? We can model with the help of ISR. You may not require this ISR for the concurrent model. So but we are having the example like this. So here you can see that ISR GUI interrupt will first get the user input data from this ISR. So first the process get user interface will get user interface input will run. It will wait for the interrupt message. If the interrupt message is being got, it will signal to the sRead coin. So after signaling this sRead coin, the process sRead coin will start up. After this, if the read coin is processing, it will wait for the other signal, that is to deliver chocolate, because this process have to check whether the given coin is correct or not. If it is the selected input and the given coins are being matched, so it can signal to the delivered chocolate. So after the signal has been generated, this delivered chocolate will invoke the process called delivered chocolate, and this delivered chocolate process can wait for the signal called as display thanks, and these kind of activities can be modeled in the automatic chocolate vending machine. See, you can model the chocolate vending machine with the concurrent model, or with the sequential model. Whatever may be the application you just want to design, you can go with the flow. That is, if you model with the concurrent model, it is well and good. If you model with sequential model, it is also well and good. But depending upon your product requirement, you have to decide with the model whatever you are using. So next we are going to see with the state machine model. The state machine model is a nice example. That is a nice example for a state machine model, which we had discussed with the digital logic circuits. The digital logic circuits, the sequential circuits can be designed as a state machine model, because whenever we are giving the input to a state machine, it will changes its states whenever the input changes. If the input and the clock is being changed at a concurrent manner, it will switch over to the state whichever we want. So we can design a machine with the states which we are designed with that particular machine, and we can design that particular machine for a software oriented approach also. So in the software oriented approach also, we may have some control oriented statements like for loop and while loop can be given as example for this FSM model. Here you can see an example for the FSM model. Here we are dealing with the another type of example, which we can say that is a interrupt service routing. Whenever the interrupt is being enabled, the ISR will be idle one, a flag will be a set one. Whenever the interrupt occurs, the ISR call will be located. So after the ISR call is being located, the flag, the interrupt flag will be getting resetted and the ISR being executed. Whenever the ISR is being executed, if either a higher priority ISR occurs or higher priority interrupt occurs, the higher priority ISR will be executed by preempting this ISR execution. So after high priority ISR is been is interrupting this ISR execution, the preemption of the ISR execution has been occurs. At that time, this ISR will be blocked. So after this blocking, the higher priority ISR will be executing the flags of this ISR. The blocked ISR will be saved as a current status, and the status values will be stored in the stack. So after this higher priority ISR is being executed, it will return to the ISR return, and this return call will go for this ISR execution. So after finishing this ISR execution, the next program, the main program, can be called back from the stack. So this is a great example for the FSM example, because we are changing the states for ISR from idle to the ISR call. After it will go to the other state called executing, and if that particular executing has been interrupted with the higher priority ISR, means it will go to the blocked, and after that it may go to the higher priority execution. Here you can also see that this is also a higher priority state. This is also another state. This state is different from this state, because this higher priority state cannot be preempted by any other ISRs, but this ISR execution, that is executing this particular state, can be preempted by any of the ISRs. So this is the difference between these two. So after the ISR will be written, and the cycle will be followed. So this is a good example for this FSM. Here is also another example.